Alright, problem 6-113. Solve each of the following equations to the nearest thousandth place. So, letter A, we have 5 and 825 thousandths raised to the power of x minus 3 equals 120. Before we get into the solving this problem here, I just want to point out we're going to be looking at using the power property of logs or logarithms here. And I just want to recap what that is, in case you don't know or you forgot already. If we look at saying the log of something, let's say base b raised to the power of x. So if we're taking the log of something that's being raised to an exponent there, that's going to be equal to taking that exponent out in front and multiplying it by the log of that base, or whatever that number was there. So essentially, it's kind of like we're just taking the exponent off of whatever number this is, and we're moving it out in front and multiplying it times just the log of that number. And it doesn't even have to be just log base 10. It could be the log of any number, so whatever you're doing to each side. So let's take a look here. Our first problem, we had 5 and 825 thousandths being raised to the power of x minus 3 equals 120. Now, our variable is up here in the exponent, and this is that new method we've learned for solving this. You know other methods. You could use guess and check, or you could graph this equation as a system of equations by graphing this side and then graphing this side and then finding this the intersection point. And this is our new method. Remember, whenever you're solving an equation, whatever you do to one side, you need to do to the other side to keep it balanced. If I wanted to square this side here, then I'd have to square this side here. If I wanted to add 6 to this side, I'd have to add 6 to the other side. So what I'm going to do here, it's no different here. If you want to end up taking the log of each side, I'm going to write that there so it stands out. I'll switch my pen size back because it keeps switching on me every single time. But if we said the log of 5 and 825 thousandths raised to the power of x minus 3, it should equal the log of 120. So more or less what I'm doing here is I'm just taking the log of each side. Because I'm doing it to both sides here, the equation should stay equal. Now this power property of log states here that what we've got up here, this exponent, x minus 3, we can now take it and move it out here in front, and we actually have the quantity of x minus 3 times our log of 5 and 825 thousandths. Okay, so it's like times like all of this here equals the log of 120. Now because we have the quantity of x minus 3 is a factor and the log of 5.825 is a factor, we can isolate the quantity of x minus 3 by dividing by our log on this side. So divided by log of 5.825. And if we do that to one side, we have to do it to the other. So we've got divided by the log of 5.825. So we have the same factor in the numerator and denominator, so that means it's going to end up giving us a value of 1. And we're left with our quantity, oops, let's just fix that. Our quantity of x minus 3 should equal the log of 120 divided by the log of 5 and 825 thousandths. Now to get x by itself here, I'm going to end up adding 3 to each side. So we'll add 3 here, we'll add 3 to this side, and you'll see we'll get x is going to equal the log of 120 divided by the log of 5.825, and then plus 3. So what we're looking at here is, you can get out your calculator. Let's pull ours out. And let's figure out what this value would be. So we're going to do the log of 120 divided by the log of 5.825. We'll take that, and then we'll add 3 to whatever we get there. So that's about 2.716, so 17 if we round it. I'm just going to do that so we know what our values are. So we had 2.717 when we round it. And then when we add 3 to that, that should give us 5.717. So x is going to be approximately that amount here. That would be our answer here for letter A. We'll write it up here. X is approximately 5.717. So just a quick recap on that one there. Because our variable's in the exponent, we can help get it out by taking the log of each side. And remember, it doesn't matter what log we use. We could use log base 2 as long as we did it on both sides there. We could use log base 3. We just use the log because that's the easiest one to type it on the calculator and the fastest. So let's go ahead and jump over to problem B. Put the calculator away for a moment here. We've got 18 times 1.2 raised to the power of 2x minus 1 equals 900. So as we look at this one, I'm going to recopy it here. Let's do this one in red so it stands out a little bit. We've got 18 times 1.2 raised to the power of 2x minus 1 equals 900. Right now we've got a factor 18 times our base that's raised to our exponent here. So before we can use the power property of logs, we're going to get rid of this 18 first. So let's go ahead here and divide each side by an 18. So when we do that, our 18s are going to divide and give us 1 over 1. So we're going to have 1 2/10 raised to the power of 2x minus 1 equals 900 divided by 18. So 900 divided by 9 would give us 100. So if we divide it by twice that amount, we should have half left, so it should be 50. And now that we have some base raised to a power here, and it equals 50, we can get our variable out of the exponent by doing what we just did. So let's go ahead and use the power property of logs. Let's take the log of each side here. So I'm going to say the log, I'm going to write it on both sides just so it stands out again. I apologize I keep having to do that, but I don't know how else to do it. There, I switched it so we're small and you can read it again. So we have the log of 1.2 raised to the power of 2x minus 1 equals the log of 50. So let's get that exponent out of here. So we're going to say 2x minus 1 times the log of 1.2 should equal the log of 50. Let's get the 2x minus 1 by itself by dividing each side by our log of 1.2. Remember, same factors. So we've got 1 over 1. And leaving us with 2x minus 1 is going to equal, and then we need to do it to the side. So we have the log of 50 divided by the log of 1.2. Okay, now before I go ahead and figure out that decimal, I'm going to go ahead and finish simplifying this, just so you're used to seeing this written as expressions with logs in them. So to solve for x, remember we want to add our 1 to each side. So I'm going to add 1. So right now I've got, let's see, 2x equals the log of 50 over the log of 1.2. And you don't have to do it this way. You can go ahead and turn it into a decimal if you want to. And then I'm going to have to take this to get x by itself. I'd have to divide each side by 2, or you could say you're multiplying this entire side here by 1/2, right? Dividing by 2 and multiplying by 1/2 is all the same thing. So x is going to equal this expression here. So let's go ahead and figure out what the decimal value is going to be, just so we can simplify it down. So let's pull the calculator out again. If you want to do it all in one big swoop, you can do that. You can type the whole entire thing in. Just make sure you put your grouping symbols in. Let's see. I'm going to start on the inside, work my way out. So I got log of 50 divided by log of 1.2. And hit enter here. I'm going to add my 1 to it. And then divide it by 2, or multiply it times 1/2. And I get 11.228. So x is approximately 11.228. Now let's talk about checking it here. Checking it's always important here. There's a couple of ways you can check. You could take your values and plug them back in. However, make sure you realize that, when you do that, let me just write that down real quick. When you do that, if you take and plug it in, remember you've rounded these values here, so it's not going to give you exactly 900 when you do that. But you can take them and you can graph them. Let's graph b just so we can see that there. Let's go to y equals, and let's type in our left side as one function. So let's do 18 times 1.2 raised to the power of 2x minus 1. Now, if you're not using one of the calculators here that you can actually write in your exponents with, then you're going to need to make sure you put parentheses around your entire exponent there. Common mistake that is made. And then let's do 900 for our second one. Notice 900 is going to be way up there on the calculator. So when I graph this initially, let's say I'm in the standard window, you're going to see that we'll see this side and it'll start creeping up here, and then we won't ever see the other side because 900 is way up here. So you could do a couple different zoom options. You could zoom out, out, out. You could try to do, let's see if a zoom fit will work on this one. So 0, and then I can adjust it from there if I need to. And there it goes up, and then you see that there, and it actually isn't even going to hit there yet. So this is what we'll do, just adjust our window. We know that we're looking for our x value to be somewhere around 11, so let's make our x max 15. And then our y max, instead of 900, let's make it, let's say 950. Then when we look at our graph, it should fit on there and we can do our second trace intersect function. So second trace, number 5, mark your functions, enter, enter, then hit for the guess, and you see the intersection should be at about 11.228. So this function will be at about 11.228 when it reaches an output of 900. Do the same thing with the other one to check your answer there. Hopefully this helps you out. This is problem 6-113 or 6-113. Thanks for listening. If you have questions, make sure you seek help from your teacher.